Hello, it's Alex here, VK2PRC, pedestrian radio calling. I'm the guy that many of you people have heard around the world, calling on my pedestrian portable station just south of Sydney. I run a Clansman 320 British Army manpack radio, and I run it into a portable antenna that I use in a portable position, usually setting up in parks and headlands and whatnot. And yes, I'm sitting on the grass or sitting in a little chair, and I talk to the world. And many people that have heard me across the world say to me, how come your signal is always so huge compared to what you're using, you know? And many times I'm likened to a 2-element beam at 400 watts. And in some instances, I'm the only station from Australia a lot of countries can hear. And they say, what's your secret? How can you do this? And I get asked this all the time, and I try to explain to people over the air, but it's a little difficult. So what I've decided to do is to put together this particular video just to explain step by step on how to do this, how to make it yourself, how to duplicate my sort of results. So yeah, so let's just get stuck into it, eh? Okay. I follow the rule of what I call my DX triangle. And these points of the triangle, in my opinion, are the most important things when it comes to my DXing around the world. The top one here is location. Many people believe that where they live is the best place to put up an antenna, and in my opinion, that's completely wrong. There's lots and lots of locations that I've got all around the place that I find that are much better than where I live, that's for sure. Comes to mind edge of the ocean, edge of lakes, headlands, nice hills that slope off long past, lots of different things that I've learnt to look for when it comes to a good DX location. So location for me is paramount. The next thing is the antenna that I use. And look, I'm looking for an antenna that's going to give me excellent performance and easy to put up and take down. The antenna of my choice when it comes to DX is an antenna that I've tried and tested many times and discarded everything else, and it's the half-wave end-fed vertical. A lot of people shy away from this antenna because it's got a very high impedance at the feed point, and it can be troublesome and cause all sorts of feedback, and well, it's all taboo. But I'm telling you, I've worked this thing out right down to a nutshell, you know, and I'm going to explain to you just how I do it. My half-wave end-fed is definitely the secret of my success, big time. We're going to get into that a little later on. Okay, and this particular half-wave end-fed vertical has a very low angle of radiation. And the last tip of my triangle here is an antenna with a very low angle of radiation, because that's how I skip a long distance around the globe with the DX. So, yep, just to summarise again, location is paramount. I'm looking for an antenna that will give me great gain, better than a dipole, and very easy to put up and take down, even in high winds, I might add. People get scared of it because it's, whoa, 10 metres tall on the 20-metre band, and how do you put that up in high winds? Believe me, it's not a problem. Okay, and the other thing is the angle of radiation that I can get with this particular antenna that really makes it accelerate and give me the results that I want. So now that I've explained that to you, let's just have a quick look at what I'm talking about when I'm talking about a half-wave end-fed vertical antenna. Okay. This particular antenna that I use is the result of many different versions and trials, and we've got this down to a fine art. So first of all, we've got a 10-metre squid pole, and we've got ourselves a nice vertical radiator around about 10 metres tall, and that's our half wave for our antenna. And I simply tape my half wave wire onto the side of a fiberglass squid pole. I don't wind it around, a bit of inductance happening there. I just tape it straight up and down. The next thing I've got happening at the bottom of my half wave end-fed is, well, we'll call it a black box for the time being, but it's actually a coupler. And what the whole idea of this particular coupler is, it's to convert my feed line here's my radio down here. I'll write that down here. Is to convert my 50 ohm impedance feed line and convert it up to approximately 3000 ohms, which is the feed point impedance of a half wave end-fed vertical. And if I can get the match perfect between here and here, I get maximum power transfer, and if I can do it extremely well, I can get a perfect match, yeah. An SWR perhaps of somewhere around about, believe it or not, 1 to 1. So we're going to try and do that, and we're going to show you people how to make this coupler. A lot of people think, wow, now this is hard, it's difficult, but I tell you it's not. And we're going to do this in the workshop, and I'm going to show you how to manufacture it, I'm going to show you how to tune it, and how to get a perfect match between your 50 ohm feed line and your antenna. Well, it looks pretty simple, doesn't it? And basically it is pretty simple. We've got an earth terminal on our coupler, and we're running a very, very short little counterpoise as well. And we're going to explain that in detail a little bit later in the video. And we're going to also install on our feed line a nice big ferrite choke. And that ferrite choke is going to help us immensely when it comes to RF feedback. So, yeah, so just to go over it again, we've got our 10 metre half wave, right up here, half wave end fed antenna. And we've got a coupler that's going to match perfectly our feed line to our feed point on our half wave end fed. We're going to have a small counterpoise to take care of any reflected currents, and I'm going to explain that a little later as well. We're going to have a little bit of a choke mounted on our feed line, and that's going to stop any RF feedback, and of course our radio. Notice there's no tuner here, okay? So all the power that's produced here ends up in here. Great match, and that will get it happening. And the most important thing of all is our angle of radiation, and that's why I picked this particular antenna for its angle of radiation. So let's just have a look at some of the alternative antennas that I could have used in my portable station, and why I perhaps aren't using antennas like that. So let's look at the very first one. Most people, I'll not say most people, but some people like to use a dipole, and dipoles, in my opinion, are fantastic antennas, especially when it comes to receiving. I love to listen to receive stations on dipoles because the noise is usually a lot lower. But as far as the angle of radiation is concerned, typical dipole, 32 degrees. 32 degrees. If I was looking at a quarter wave vertical antenna, and by the way, I'm a great fan of quarter wave vertical antennas, but maybe not as good as this for DX work. Medium DX work, I love them. Down near the ocean, I really like a quarter wave as well. But away from the ocean and near the ocean, I still prefer this one here. So when we're looking at our quarter wave vertical, as far as the angle of radiation, around about 26 degrees. Okay, so lastly, our half wave end-fed antenna has got a typical angle of radiation around 15 degrees. 15 degrees. So when it comes to DX, we've got the long skip happening. The long skip. And that's what gets me around the world, is this low angle of radiation. Good gain, good match, good power transfer. No RF problems with a low angle of radiation. It's not Einstein and it's not rocket science, but that's how I do it, along with location. And yeah, I'm the little guy that sounds like a big guy. So lots and lots of people would like to have a station like mine, and this particular video that we're making here today is going to explain to you people how to make an antenna like mine. So in the next portion of this video, we're going to move to the coupler and how to make this coupler and how to tune the coupler, and then we're going to come back up and put the antenna up and show you the results of how to get it all together. So lots of different sections in this video. This was the first section, basic explanation. The next section that I've made is up at the park. We're going to have a look at one of these up and in place. We're going to identify the different things, have a little bit of a talk about it. Then we're going to go down to the workshop, make the coupler. Then we're going to tune the coupler. And then we're going to come back up to the park, put it back up again, show you the coupler in operation. We're going to check the SWR of the coupler in situ, in the field condition. And we're going to have a bit of a look at the performance of the antenna and where it's situated, etc. And ideally, at the end of this video, you people who are interested can go away and duplicate exactly what I do and perhaps get exactly the same results that I do, and that would make me very happy. Thank you very much. See you up at the park. Here we are up at my local park. I've put up the half-wave end fed, you can see it there, 10 metres high, of course made specifically for the 20 metre band. So let's go up and have a bit of a closer look and identify the parts. This is a typical sort of location where I would normally run my portable station. It's a lovely hill here, and just when we get to the antenna I'll just do a quick sweep around. You can have a look at the type of place that I would normally run my antenna. Okay, we've got this lovely park here. It's right on the top of a hill, right in the middle of town actually, and it's got a fall off, you know, all the way around, which works extremely well. From this location here I've spoken to, well, many countries all over the world. So yeah, and of course we've got the radio down the bottom, so let's just go through all the parts one at a time and sort of recognise each part. So looking at the antenna all the way up there, yep, of course we've got our driven element, and the driven element here is just made up of a normal bit of speaker wire that I've torn in half and soldered the two halves together to give me my 10 metres half-wave in-fed antenna. And plugged in to the driven element we've got the coupler, and this particular coupler here is used to match the high impedance of the half-wave end-fed to the 50 ohm transmission line. And you'll notice there's an earth terminal here on the coupler, and from that earth terminal I run a couple of radials, and these particular radials, they're just thrown on the ground as you can see. Yep, and they just happen to be approximately 5 metres long. There's no real need for specific lengths on these, and yep, there's the two of them there. I've just got them thrown out there on the ground. Typical counterpoise. Now you're probably thinking a half-wave end-fed doesn't really need a counterpoise. Well, as I mentioned before, in most installations that people use half-wave end-fed antennas, they're used in QRP operation. And in QRP operation, if we get any common mode current, it'll return or conduct down the outer shield of the transmission cable. And it's not a problem because it's just so small and tiny, it doesn't become any problem at all. But when we start using an antenna like this, and we start using a bit of power, especially heading up towards 100 watts, the common mode current increases accordingly. So what we need to do is we need to actually start looking at getting rid of the common mode current on the transmission line. And look, the best way to do this is to just throw out a couple of counterpoises or radials to take care of the common mode current. And also what we do on the transmission line, we install a nice big ferrite choke. This particular ferrite choke won't let the common mode currents pass through it and down to the radio, so that they're forced back up again and forced into the counterpoise and dissipated that way. So that takes away any feedback problems or RF burns, or any sort of problems that you might encounter with a half-wave end-fed that a lot of people sort of shy away from. But simply a nice big ferrite choke for me fixes that completely. Okay, so what I've done, I've mounted my half-wave end-fed into a bit of PVC pipe, as we can see here. and the PVC pipe comes down. In fact, I've got a couple of sections of it that plug into each other, and then in this case I've mounted a nice bracket that I've made, purpose-built bracket, and this particular bracket fits over the poles that you see in the park. So anytime I go to a park that's got poles like this, I'm able to use my bracket and mount my antenna very quickly. Okay, if we follow the transmission cable down, we'll come to the set that I usually use, and this is my Clansman 320. Yeah, it's a British Army man-pack radio. You can see it's mounted. This one here I've got mounted in a Bergen, and the Bergen is generally carried on a soldier's back, and also the radio can also be fitted to a vehicle as well. And if you're interested in what sort of a vehicle this radio would be fitted into, let's swap over and have a look at a typical vehicle that this radio would be in. Okay, impressed by that? That's just one of our toys, and this particular radio does mount in that toy. And just for the information of people that are watching this video, I've mounted this antenna on top of that vehicle, and actually spoken to many parts of the world from sitting in the back of that vehicle, which has been quite exciting. But for those people who are familiar with the Clansman radio, they will know that there's a thing on the Clansman radio called the reflector meter, and that's the reflector meter there. So it's an indicator of just how well an antenna is tuned to the radio. And ideally, if this flips over to about the 3 o'clock position when I press the ant function on the radio, it means it's almost a 1-to-1 match. So let's just hit it now and have a look at the match we've got. Very close to a perfect match there, and that's a fantastic match. So no tuner required here, straight out of the radio through the transmission line into the antenna. So there we have it, guys. Half-wave end-fed, made specifically for 20 meters. This is the one that I use to DX around the world. Next stop will be the workshop, where we're actually going to go through the steps of actually making a coupler that'll match this antenna, and also tuning the coupler to get it to the perfect 1-to-1, so we can get full power transfer between the radio and the antenna. And you'll notice here that there's a piece of coax coming out of the bottom of the coupler and going down here and going nowhere. This particular coaxial cable, this is how we tune the coupler. So yeah, all will be revealed in the next section of this video. See you all in my workshop.
Okay, what we're going to do in this section here, we're going to talk about matching the 50 ohm coax feed line to the very high impedance of our end-fed half-wave antenna, which is going to be approximately 3000 ohms. Not only are we going to build this particular coupler, but we're going to tune out any inductance in the coupler with a capacitor. Rather than use a standard variable air capacitor or a fixed capacitor, what we're going to do is we're going to use a piece of coax cable, and we're going to trim it to the required length to give us the capacitance. So in other words, we're going to use this piece of coax cable as a capacitor, and we're going to vary it by trimming the length of it to tune out any inductance in our coupler so that it matches perfectly and gives us almost, hopefully, a 1-to-1 match to our antenna. It's a pretty nifty idea. The whole idea of using this coax for a capacitor is it will withstand a lot of voltage. And well, if we're going to use a lot of power with this particular antenna, we could create quite a high voltage across the capacitor, hence the coax cable, and then that'll withstand the high voltage for a capacitor, and that's about it. And it's pretty easy to use and pretty easy to get as well. So let's have a look at some of the other hardware that we're going to use here. to make our coupler. So simple piece of coax cable. We got a UHF a terminator. We've got a toroid, a T200-2. You might think this is rather a large toroid, but the whole idea of a large toroid is this particular coupler that we're going to make here is going to be capable of taking powers, say, from 10 watts right up to 400 watts. So if you wanted to build a 400 watt half wave vertical end fed antenna, you could use this particular coupler, not a problem. Also, we've just got an earth terminal and an antenna terminal. Yep, pretty simple. We mount all those things in a project box, and we're gonna show that next. And then once we get it into our box, we're going to trim back our coax capacitor to get a perfect match between our 50 ohm coax and our antenna. Now, we're actually going to tune this particular coupler here on the bench rather than in the field. All we're going to do is replace the antenna with a 3000 ohm metal film resistor, approximately 3 watts. And we're going to connect that temporarily between the antenna terminal and the earth terminal, and then we're going to tune our whole device to hopefully get a good SWR reading, say between 1.2:1, possibly down to 1:1. Yeah, which will be really, really good. If we had if I had the pleasure of owning an antenna analyzer, I could connect it on here and do the tuning with that. But don't have one of those, so I'm just going to use my SWR meter. So let's go through the wiring of this and how we connect it all up, and then we'll actually have a look at the real thing. Okay, so let's start off here with the earth terminal on the coax terminator. Okay, so we come from the earth terminal, and we actually join up to our earth terminal, and we also join to the braid on our coax capacitor that we're going to trim off later on onto the braid, and then away we go onto the toroid. Now the toroid has got a ratio of 2 turns to 11, 2 to 11, and every time our conductor passes through the inside of the toroid, it counts as 1 turn. So let's follow our wire here. It goes under the bottom of the toroid, around 1 turn, under the bottom 2 turns, and across. So there's our 2 turns, and from there we tap off and we go to the inside terminal of our coax. Okay, so there's our 2-turn primary. So let's now go to our secondary. So from here we go underneath, across the top, 1 turn, 2, 3, 4, 5, 6, 7, 8, 9, 10, coming up from the bottom, 11. That's the 11th one there, and then off it goes to here. From there, connects to the antenna terminal, and also connects to our coax capacitor that we're going to use to tune out any inductance of this coupler. Now, as I say, for the load, we're going to connect temporarily a 3000 ohm metal film resistor, approximately 3 watts, and we're going to use this in place of our antenna to do our tuning of the box. Now, bear in mind when we apply a signal to this particular thing and carry out the tuning, that we only sort of apply something around 5 watts or possibly less to do this tuning. If we were to connect this thing up to 100 watts, we would simply blow up the metal film resistor. It couldn't handle it. So bear in mind, we're going to tune this at very low power, and yeah, so basically that's our antenna coupler. Just again, as a summary, what it's going to do, it's going to match the 50 ohm coax to the 3000 ohm antenna, and we're going to do that by using an auto transformer, 2 turns to 11, and we're going to tune out any inductance with our tuning capacitor that we're going to trim back to the correct size to give us a perfect match between the input and the output. So in actual fact, we're going to create maximum power transfer between the two. So let's now put this aside and have a look at the real thing. Okay, let's look at the actual coupler that we're making here. First of all, I've mounted this one in a nice little sort of a plastic project box. We've got our UHF terminator here coming in for our coax feed line. We've got our earth terminal, we've got our antenna terminal, and of course we've got our 200-2 toroid. Okay, and you'll see here I've got the coax tuning capacitor. We're going to tune that in the next stage, but as you can see, it connects to the earth terminal and the output antenna terminal. If you look carefully, you can see the 1, 2 turns of our primary and the 11 turns of our secondary. You'll also notice on the outside here, I've got mounted my, well, I've used a couple of resistors in series to make up my 3000 ohm load, so that we can tune this thing here in the workshop. But basically that's the finished item, and what we're going to do next is we're going to tune it to get the maximum power transfer between our 50 ohm feed line and our approximate 3000 ohm load for our antenna. Okay, in this section what we're going to be doing is tuning the coupler to our 3000 ohm resistor. As I mentioned before, this is a means by which we can tune this coupler in the workshop so that when we go out in the field it'll be perfectly tuned for our antenna. And what I'm going to be doing is trimming the coax capacitor to the right length to give us the correct capacitance, so we can get a very good match between our 50 ohm input to our 3000 ohm load. And remember, this resistor replaces the antenna here in the workshop. So what we're going to be doing is taking the end of this this coax capacitor here, and I'm going to be trimming it back by about 1 centimetre or so at a time as we move down towards a good match for our antenna. So over here I've got my SWR meter. Yeah, look, I've replaced the meter here with this big one. So we're coming from the radio here, and I've actually got a radio connected to there where I've got it set to AM, so to give me a good amplitude modulated signal to do this test, and it's putting out about 7 watts at the moment. So the resistors here should be able to handle that momentarily, and we can tune it. The frequency that I've got selected here is the 20 meter band, of course, because we're making a 20 meter coupler, and I've set it on 14.2 megahertz. So let's move in towards tuning the length of our coax coupler. Coax should say coax capacitor on the coupler to the right length to hopefully to get this thing tuned properly. So let's have a bit of a look and see where we're at the moment. So I'll set her up here on forward, and we'll have a look. So we've got full scale there on forward. Yeah, pretty good. And I'll go back to reflected, and whoa, not a very good match at all. Pretty terrible match, really. So we'll have a look at that. So what I'm going to do now is I'm going to trim a little bit back on my capacitor, and we'll work our way down. Oops, dropped my side cutters. So I'll pick them up and we'll carry on. Okay, here we go. I'm going to get a, whoops, I'll just cut a piece off here. And we'll do ourselves another check. Forward. I'm off to the side here a little bit, so there. Reflected. I see an improvement there, so I'll chop a bit more off and carry on. And of course, when I've completed this, I'll do a measurement and we'll see where we sort of end up at. So back to forward. Reflected. It's improving. We're heading in the right direction. Another bit off. too far. As I say, I'm down to probably just under a centimetre a click here now. Wow, pretty close now. Reflected. So that's less than about 1.4 to 1. I might give it another little click. Reflected. Whoa. That's about 1.2 is to 1. I might be cheeky and give it another tiny little click. Reflected. Absolutely no movement at all. Okay, my little resistors here are starting to warm up. I better be careful. So that is about 1.1 is to 1. So that's as close as I think I want it. That'll do me. That's pretty well a perfect match. So what I'm going to do now is I'm going to trim back just the PVC on the braid here, and I'm going to pull the braid back a little bit from the end, and I'm going to get a hot glue gun, and I'm just going to put a big blob of hot glue right on the end of here just to seal the end of the capacitor so that we don't get any moisture in there, and that should pretty well match it perfectly for when we get up in the field. And when we get up there in the field, we'll do this same test again, and we'll just see how close it ends up. Okay, here we have our completed coupler. The tuning capacitor ended up 525 millimeters long. You'll notice I've taken the end and I've peeled back the installation. I've put a nice big blob of super hot glue with my glue gun on that to seal it up. So that's a really good idea to do that. Also, I sort of separated the shield from the inner core as much distance as I could before I put that on there, so there's really reduces any chance of any arcing. The box itself, you probably noticed that my UHF connector here is a little bit off center. I've just allowed a little bit of space to get the screw down in there to mount it on my little portable mast. We've got our earth connector and the connector at the top here for the driven element. So yeah, I'll just turn the box over and have a look at that. So there's our completed half-wave end-fed coupler for 20 meters. Next stop in the field, and we'll see how we go. Okay, we're back up here at the park to do the test on the coupler to see how well it's matched in the field with the SWR meter. So here we've got our radio connected to our SWR meter, and of course we've got our half-wave end-fed vertical going up there. It's quite a windy afternoon here in the park, and you could probably see him bend him over, but yeah, no trouble in the wind for this guy. Okay, so I've already checked on the frequency, and there's nobody on the frequency at the moment. So we'll do our test, and we'll see how we go as far as our match is concerned. So I'll slip our meter over into forward, and we'll see how we go. Yep, that's forward exactly. I'd preset that before. Switched over into reflected, and let's have a look at our reflection. Whoa, I'll just get a reading on that. Very, very low. Okay, the reflected is about
1.1 to 1. So very, very happy with that. Our coupler is absolutely performing perfectly. It's around the other side there. This particular box on this side is used for another purpose, so don't worry about that. Okay, so that's the test. It just goes to prove that the setup in the workshop works extremely well when we get into the field. And it's worth mentioning that if you get a reading that's a little bit high in the field, you're definitely going to have to resonate your driven element. So go through the same procedure as trimming it back to resonate exactly on the frequency that you want it to work on, and you should get a very, very low SWR reading and a great match for maximum power transfer.
Okay, in this last test here, what I'd like to demonstrate is the effectiveness of the RF choke here, and the absolute need to have one. Pretty well, a lot of the stuff you read on the internet says that, you know, a half-wave end-fed really doesn't need any counterpoise, but the whole purpose of my counterpoise is to get rid of any common mode currents. So I must say that this half-wave end-fed does produce common mode currents, and we need to look after them. So that's why we installed the RF ferrite choke. So what I'm going to do, I've got a field strength meter here. I'm going to take a few readings up here around the feed point and up on the radiated element, and I'm also going to take a few readings on the counterpoise, and then we're going to go and take readings on the feed line going down to the radio. So I'm going to whistle to generate a signal on SSB, and I'm going to take some readings. You may not be able to see the needle itself, but I've got it set very sensitive, and I'm expecting like full scale deflection. So here we go. Righto, first of all we're going to go up near the driven element. Okay, we got a slamming across, full scale deflection, just about broke the meter. Alright, the next reading here we're going to go down and have a look on the counterpoise and see what sort of RF's generated on the counterpoise as well. Okay, we're getting a soft full scale deflection on the counterpoise, which illustrates, yes, there is common mode currents flowing in the counterpoise, which is good. So I'm now going to have a bit of a look at the actual feed point where it goes onto the coupling box, and I'm expecting to find common mode currents flowing on the outer shield as well. So here we go. Full scale deflection again on the other counterpoise and on the feed point. Okay, so definitely got common mode currents flowing there. So for my last test, I'm going to go down and I'm going to test the coax itself just as it gets down near the radio, and I'm going to look for, you know, any sort of radiated energy coming from the shield of the coax down here. You probably won't be able to see this, but I'll do it and I'll tell you the results. The needle never moved at all. Maybe you can see it halfway down, I'm not sure. Okay, and down further, absolutely none. So our choke, our RF choke, is doing a fantastic job. So what's happening is common mode currents are being produced by the antenna. They're coming down the outer surface of the shield to here. They're hitting the choke, they're being reflected back up again, and they're being forced down into the counterpoise, and the counterpoise is dissipating them, hence no feedback problems with my end-fed half wave. So there you have it, in operation, beautiful match, and no problems with RF feedback. So the next thing we've got to do now is get it on the air and see if we can make a few contacts. VK2PRC, good afternoon, Jonathan down there in Tasmania, mate. Good to hear you, over.
Okay, Alex, well, you've got you a nice signal here. I've got you at a fairly solid 5 and 9. I think it did touch a tad over, and I'm not running any preamp, so that's a straight signal reading.
Well, there we go. Only a couple of calls and we're straight into Tasmania. about 2,000 kilometres at 59 plus, so typical of the sort of signals that we get with this antenna. So yep, I hope you've enjoyed the video that I've made. A very easy project as far as I'm concerned, and a project that has very, very good results, and you couldn't do better as far as the DX antenna is concerned. So I wish you all the best. This is Victor Kilo 2 Papa Radio Charlie, pedestrian portable, saying cheerio and good building. Catch us again. I'll take the mobile station over. Japan Sierra 1 kilowatt Sierra uniform. Good afternoon, it's Alex here, mate. Victor Kilo 2 Papa Romeo Charlie here. Campbelltown, New South Wales, over. Roger, Roger, thank you very much for the 5x5 into Japan. That's great, mate. Your signal strength at this end is pretty low, my friend. You're about a 51, 52 here. A lot of QSB this afternoon, over. Before you go, Mick, is this Mick from the WhatsApp group, the real HF mobile, over? Roger, Roger. Yeah, it's Alex here, Mick. I belong to the same group, mate. The real HF mobile group. Great to bump into you on the air, mate. Always a pleasure, over. Yeah, Juliet Sierra 1 Kilo Sierra uniform. Thank you very much, Mick. Always a pleasure to catch up with you blokes, mate. Sayonara. Catch you again. Bye-bye. Yeah, amazing. That's Mick from Tokyo. He operates from his van down near the beach. Only this time of the year I managed to get in contact with him, so always a pleasure. This is Victor Kilo 2 Papa Romeo Charlie here, pedestrian portable, calling CQ, looking for any station. Victor Kilo 2 Papa Romeo Charlie, pedestrian portable, calling CQ, over. Okay, I'm getting a station there rather weakly. I think it's a Foxtrot station. Could I just get the call sign again, please? Over. Roger, Roger, got that. Florida 4 India Victor. This is Victor Kilo 2 Papa Radio Charlie, pedestrian portable here. The name's Alex, mate, over. Yeah, thank you very much for the 5x5. Your report is a little lower, my friend. You're about a 5x3. About a 5x3. Can you tell me your QTH? Where's your QTH, over? Roger, Roger, thank you very much for that. You're about 500 kilometres from Paris. Well, that's fantastic. This is a great DX call for me. Very surprising with very poor propagation this afternoon to get into Europe. Yeah, fantastic. You're talking to Alex here, mate. Alpha Lima Echo X-ray. Alex, transmitting about 40 kilometres southwest of Sydney, over. Yeah, Fox 4 India, Victor, good afternoon. You're operating a 4-element beam facing long path. That's fantastic, mate. My station here is very small, my friend. I'm sitting here operating my British Army military radio and operating only 25 watts into a halfway vertical antenna, over. He's pretty surprised. Yeah, Fox 4 India, Victor, thank you very much for the contact. Always a pleasure speaking to you guys in Europe, and very surprising on such a poor afternoon. But thank you very much. Catch you again. This is Victor Kilo 2, Papa Radio Charlie here, pedestrian portable, mate. 73. Catch you again. Okay, guys. So there was a call there on an afternoon where the propagation forecast was poor for 20 metres, and here's the half-wave end-fed talking between Sydney and Paris. He's giving me a 5x5. So that's a pretty spectacular sort of performance from a wire antenna in a park on a hill here in Sydney, especially at the bottom of the solar cycle. So I'm pretty happy with that, and I think that anybody out there would be pretty happy with a result like that as well. Let's keep going and see what we can do. CQ, this is Victor Kilo 2, Papa Radio Charlie, calling CQ, standing by. CQ, Victor Kilo 2, Papa Radio Charlie, pedestrian portable, calling CQ, standing by. Yes, I got you loud and clear. The name here is Alex, mate. Alpha Lima Echo X-ray, transmitting out of Campbelltown, New South Wales this afternoon. Talking to you on my British Army military backpack radio. An absolute pleasure. Can I get your name, please, over? Yeah, good afternoon, Starman. Nice to meet you, mate. Could I get that? Could I get your station call sign again? I missed it on the first over, mate. I'll just read that back to you. Alpha 1. Is that correct, over? Roger, Alpha 1, that's a pretty strange call sign. Are you a special event station? Or what country, over? Roger, you're a mobile station, and you're mobile at the moment. You're actually in a Tesla Roadster. Is that correct, over? Yeah, roger that, roger that. You're in a Tesla Roadster, and you'd like me to pass a message on to somebody. Yeah, I can do that. I've got a mobile phone here. Who would you like me to send a message to, over? I'll just repeat that back to you. A guy named Elon Musk, is that right? Elon Musk? Roger, all I have to do is Google him. Is that right, over? Yeah, okay, I can do that. Tell me, what's the message? What's the message, over? Yeah, roger, roger, I got that. You want me to tell Elon Musk that you're just passing Mars orbit and you're heading into deep space and everything's okay? Yeah, I can do that. Yeah, okay. Roger, roger, I'll pass that on. I'll just get you to hold on for a minute. I'll be back in a sec. Okay, everybody, there you go. The longest DX ever. No doubt about the half-wave end fed. It's the DX antenna of choice. Absolutely a good performer.